In the second part of Unit 3, we are going to look at gravimetric analysis, which are analysis which depends on the measurement of the mass of reactants or products, as opposed to the measurement of the volume of samples, as we came across in the first part, the volumetric analysis. You'll carry out 2 experiments, and by the time you've completed them, along with the associated exercise files, you should be able to explain the circumstances which would allow a gravimetric analysis to be appropriate. You should be able to explain what is meant by the term heating to constant mass. You should understand the role of the desiccator in gravimetric analysis, and you should be able to calculate unknown concentrations from the results of gravimetric analysis. The title of experiment 4 is the Gravimetric Determination of Water in Hydrated Barium Chloride. Now, most salts exist in either a hydrated or an anhydrous state. The salt you're going to be looking at in this experiment is barium chloride, and it can exist in either of these states. Anhydrous barium chloride has a chemical formula BaCl2, whereas the hydrated barium chloride has a chemical formula BaCl2 and then X number of moles of water, H2O. So within every barium chloride unit there's a certain number of moles of water, and what you have to do in this experiment is work out the value of X. Is it 1 mole of water for every mole of barium chloride, 2 moles of water, 3, 4, 5, 6? What you have to do is you will measure out a known mass of hydrated barium chloride and then remove all the water by heating it in a Bunsen burner. Then by reweighing it, the difference in the mass will tell you the mass and hence the number of moles of water associated with that given number of moles of barium chloride. Now, because this analysis depends on the measurement of mass as opposed to, say, volume in the previous experiments, this is known as a gravimetric analysis. Okay, so the first thing we're going to do is we're going to heat up the crucible for 10 minutes in order to get rid of any water that might be absorbed onto the surface of it. So we want to use the blue flame at all times, because if we don't use blue flame we'll get some carbon deposits on it which will mess up our weighing. Okay. So we're just going to roast this for 10 minutes just to drive off any water. Okay, so we've now heated it for 10 minutes and I've just let it cool down a wee bit, and what we want to do now is weigh it. However, because it's still very warm, if we put it onto the balance, convection currents produced by the hot crucible will actually interfere with the weighing process. So we have to let this cool down to about room temperature before we weigh it. Now the problem with that is that as it cools down, it can reabsorb moisture from the atmosphere. So to stop that happening, we're going to put it into this desiccator. Okay. So just a few points about the desiccator. Okay. At the bottom of the desiccator, we've got a drying agent which absorbs all the water from the air in the desiccator. Okay. Whenever you pick the desiccator up, make sure you hold it by the bottom and the lid, okay, because the lid just slides off. So I want to transfer my crucible into the desiccator now to allow it to cool down without reabsorbing water from the atmosphere. So I'll put it in there and leave it for about 5 minutes. Okay. So we've let this cool for 5 or 10 minutes. So we're now going to weigh the mass of our empty crucible plus the lid. Zero the balance. You might get a bit of movement on the third decimal place. There's not much we can do about that. And it's important you don't touch the crucible with your hands, or grease from your hands can get onto it and interfere with it. So the mass of our crucible plus lid is 19.888 grams. So I record that, 19.888 grams. And now I'm going to add some of the hydrated barium chloride. So now what I want to do is add approximately 2 or 3 grams of the hydrated barium chloride to the crucible. So take the lid off. I haven't zeroed the balance, but obviously it's dropped now. It says 11 point, well, it's just almost exactly 12. So I'll add some barium chloride till we get up to about 14. That's 12.8. 13.6, just a wee bit more. So that's reading 14.3. I'll put the lid back on. Oops. And record the total weight of the crucible plus our barium chloride, which is 22.269.
Okay.
So I've left it to cool for a couple of minutes. I'm now going to transfer it to the desiccator to leave it to cool for about another 10 minutes. So very carefully transfer it. And we'll leave it in there to cool for about 10 minutes. And while it cools down, it's not going to reabsorb water from the atmosphere because the desiccator keeps the moisture levels in air down to almost zero. Right, I'm now going to heat up the barium chloride salt to drive off the water. Now you'll notice that the lid is not entirely covering the crucible, just to allow a little bit of space for the water to escape. Now it says you should heat it gently for the first 2 minutes. To heat it gently, it doesn't mean you use a yellow flame, you still use the blue flame as always. But for the first couple of minutes, you alternate for about 15 seconds heating, and then after heating it for 15 seconds, remove the heat source for about 15 seconds. This is just for the very initial heating because this is when most of the water will be driven off. Okay, so heat again for 15 seconds. And then off for 15 seconds. Then after doing that for about 2 minutes, just leave the Bunsen under for about 10 minutes. Right, so the sample has been cooling down for about 10 minutes, so we can now weigh it carefully. So put it onto our zeroed balance, along with the lid of course. Let it settle, and our new reading is 21.940. I'll put it in for the second reading, 21.940. My first reading was the 22.269. So we've dropped from 22.26 to 21.94 due to the loss of water. Okay. Now we're going to repeat that whole procedure again, until we get two results that are within 0.002 grams of each other. At that point we can say we've driven off all the water and what's left is just the barium chloride. It may take 3, 4, 5, 6 cycles before you get two results within 0.002 of each other. You just need to see what you get. Our third measurement of the crucible and the salt gave us a mass of 21.915. So the mass had continued to drop as we were still losing some water. Our fourth measurement gave us 21.909. So not dropping nearly as much, but still greater than 0.002. Our fifth measurement gave us a value of 21.907. And because results 4 and 5 are both within 0.002 of each other, that is defined as no further mass loss. And that's the sample dried to constant mass. So for our dried weight, we take the average of these two values, which is 21.908. So first thing we have to calculate is the mass of the anhydrous barium chloride, which is the difference between this weight, which is pure anhydrous barium chloride plus a crucible, and this weight here, which is the crucible weight. So it's 21.908 minus 19.88, which equals 2.020 grams. And now we have to calculate the value of N in the equation BaCl2 NH2O. So first thing to do is calculate the number of moles of barium chloride we have in 2.02 grams. So it's 2.020 grams divided by the gram formula mass, which is 208.3, which gives us a value of 0.00970 moles. Now, the number of moles of water, well, first thing we have to work out is what mass of water we had. So the mass of water is the difference between that value there and that value there. Okay, so it's 22.269 minus 21.908, which equals 0.361 grams. So the number of moles of H2O is 0.361 divided by 18, which equals 0.0201 moles. So when we had 0.00970 moles of barium chloride, we had 0.0201 moles of water. So if we divide both sides by 0.0097, we get 1 mole of barium chloride corresponds to 2.07 moles of H2O. So it's more or less a 1:2 ratio, so the chemical formula is BaCl2.2H2O.